Hello. Good evening. Hope preparing well, working really hard. Uh, we had few topics left from the previous magazine also, right? So I would ideally want to finish that first, and then I would want to start the updated magazine, जो है हमारा. We should do that, right? And we should first finish the some of the topics we did not discuss in previous classes. We had done till defense, if I remember correctly. And जो last के दो topic थे, awards and prizes and miscellaneous topics, that we could not complete. So let's start today's class with this one. The previous magazine, not the updated magazine, the previous magazine. And let's go to page number 81. Now this topic, जो first topic आपका है और जो Nobel Prize in Physics है, it's not very simple, it's not very straightforward. But without making things complicated, how can we appreciate the significance of this topic for prelims examination? So I will focus upon that only. That let's focus upon what type of questions I expect from this topic and how to appreciate this particular topic. So the Nobel Prize in Physics was given for attosecond physics, a branch of science which deals with very small light pulses which exist for a very small period, 10 to the power minus 18 second. So 1 attosecond is a very small period, 10 to the power minus 18 second we are talking about. And just to give you some context, which is also, I am very sure that in material also this might have been given, that compared to 1 attosecond, 1 second is exactly as much as compared to 1 second what is, let's say, 10 billion years. So we are talking about a very small light pulse which exists for a very, very small duration, 10 to the power minus 18 few attoseconds. And this group of scientists, the three scientists in fact, they were the first group of people who successfully developed attosecond pulses into their own lab, and for that they were recognized. So that is the first thing that we should know. This in itself is important. Nobel Prizes always will be important, although UPSC has not asked questions a lot. Like in mains they have asked questions, but in prelims it's been quite some time that they asked a dedicated question on Nobel Prizes. So यहाँ पे context भी ज़रूरी है that this Nobel Prize was given for attosecond physics. Now to appreciate that, let's understand some of the very basic events. Imagine that a fan is moving really fast, and try to take a picture with your simple mobile phone, with this mobile phone, and it will be a blurred image, right? It will not be that those three blades which you see in your fan, you'll not be able to resolve them separately. You're going to find a blurred image. Why is it so? The reason is very simple, because iska jo bhi frame rate hai, that frame rate is less than the speed of the fan itself. It cannot individually resolve all of those three blades separately, and you are going to find this blurred image. So this is about frame rate, but at the same time, events which happen so rapid, and we use light pulses whenever. So light is a information carrier. I use this statement a lot, that think of light carries information with it, all type of information. For example, in this room you have light, and this light gets reflected from all of you, reaches to my eyes, and that allows me to see all of you. So that light, when it is reflected from you, it allows me to look at you. So in a way, that light is carrier of information. Now in this particular case, it allows me to look at different colors, your shape, your geometry, topography, various other objects in this room, all of that thing. But we can make much more sophisticated device. Light carries various types of information. It's not just the color or shape or size or topography which light, it can tell you about a lot of things. But not all events happen in a time frame which is suitable for our eyes. A lot of events happen so rapid that it does not even make sense for us to even imagine that how rapid these events are. But the fundamental law of nature still applies, that if an event is happening very rapidly, then to know about that event, I need a light pulse which is happening faster than that. So I need a light pulse which exists smaller than that particular event. So इसको आप ऐसे भी समझ लो that मेरे पास जैसे मान लो कि I can just by looking at this pen, I have a sense of its dimension, that how long this particular pen is. But imagine thinking about think about that आपका जो A4 शीट का जो A4 पेज है उसको आप 10 पार्ट में बांट दो. लेट्स गो टू लेट्स से 1 micron meter. I have no perspective. I cannot imagine that 1 micron meter. I cannot imagine very small things. So the reason why I can imagine this length of this particular pen here is that I'm using light to measure its length, and the light ka wavelength hai, that is very less. It is in nanometer. It is much less than length of this pen. So if I have to imagine things which is less than light's wavelength, let's say for example an atom will have dimension in the sense of angstrom, and then I do not have any perspective about the dimension of an atom. So whenever we measure things, we have to measure things from a scale where the scale in itself is smaller than the actual thing we are trying to measure. And that is also true in case of when an event is happening in a particular time period, an event which happened very rapidly. So to monitor that event, to know more about that event, I need a light pulse which exists even for a smaller duration that particular event. So why I went into this much of detail? Because जो electrons का जो transition है, when electrons are not at all static particles inside atom. Electrons have many shells around the nucleus, and all of the time they are moving around these various shells, but all of the time they are jumping from one shell to another shell by absorbing energy. And whenever they come back from higher energy to lower energy, they emit energy. But that transition from one energy level to next energy level, that happens in attosecond. So while atomic phenomena may happen in femtosecond will be 10 to the power minus 15 second, but the transition of elementary particles within atom, particularly electrons, that happens in attosecond. And that is why we need a light pulse which only exists. So for example, imagine no light pulse. Suddenly you have a burst of intensity, a light, and then again it vanished just after 10 to the power minus 18 seconds. So light pulse, which only exists for one attosecond or few attosecond, that will allow us to know about what is actually happening at the level of electrons. So the group of scientists, this three group of scientists, they were able to develop a light pulse which exists for few attosecond, for 50 or 100 attosecond. And as of now, people can develop a pulse of even less than 10 attosecond. So what started with 100 attosecond? In fact, what started with femtosecond? A typical laser beam hai, that is of femtosecond, 10 to the power minus 15 second. And with the help of those femtosecond pulses, they were able to develop attosecond pulses, which is 10 to the power 18 minus 18 second. Why? Because this pulse will allow us to know about those events which are even less than 1 femtosecond, and events which occur in the range of attosecond, 10 to the power minus 18 second. So this is the significance of this discovery, and that is why Nobel Prize Committee recognized this discovery and they were given Nobel Prize. But how did they do that? Now that is actually much more complicated. So I will not go into a lot of details of that, but I will tell you the fundamental basis of it. They used a laser light which already is of femtosecond pulses. हमने awards and prize section is completed in the previous classes, have we? तो हम क्यों कर रहे हैं फिर ये? अभी तक किसी ने क्यों नहीं बताया? Briefly बताया था. अच्छा तो ये अगर हमने कर रखा है तो फिर दोबारा करने की जरूरत नहीं थी. तो यहाँ पे जो only thing which we need to, so I will quickly summarize them. We already have discussed it. I thought that I haven't actually discussed it. So the technique they used is called higher harmonic generation, and higher harmonic generation is a technique where just what they did here is that they used laser light, laser pulse of femtosecond, and they ionized an inert gas such as neon. Because so neon is not very much active. Neon ke jo electrons hain, they are quite happy in their own shell, but because of this excess energy they receive from laser, the electrons come out. But then we force those electrons to enter inside atom within an experimental setup, and that leads to now production of its own light. But that light now will be in some sort of multiples of that actual light we started with, and then we are going to cause constructive interference and destructive interference, and we will produce attosecond pulses. All of that, we do not have to go into it. You just have to remember three keywords here, one keyword here: higher harmonic generation. So the method which we use to produce attosecond pulses, this method is called higher harmonic generation. So for examination, I will remember this keyword, higher harmonic generation. That was the method which was adopted by this three group of scientists to develop attosecond pulses. Why part is more important? Why attosecond pulses? That is more important. And what will be the utility of that? So it allows us to now look at the atomic and molecular changes in a better way, and perhaps it will allow us to develop electronics, computational devices. Once we know, have better control about how electrons actually transition, then we can develop better devices, and those devices can have applications in better computers or even in diagnostic devices in healthcare, various other things. So applications is endless. So the more we understand about atomic and molecular phenomena, and in this case particularly about how electron changes its position or how it transitions from one energy level to another, that allow us to think, that allows us to develop various types of things. Quantum dots, few things. Quantum dots are nanoscale semiconductors. So semiconductors, we already know about that, but we are now talking about miniaturized version of these semiconductors. I feel like that I'm repeating this. I am going to skip these two topics. मतलब नहीं है जब हमारे पास already बहुत सारे topics हैं जो हमको complete करने हैं. So once I somehow in my mind I thought that I haven't discussed actually these topics. Rare Higgs boson decay, that topic is not important per se. What is important is the underlying keywords which is given in the material. So rare Higgs boson decay happened, वो important नहीं है. That some reaction which Higgs boson undergoes through, that is not important. But we should know about the concept of Higgs boson itself, and we should definitely know where is it happening. So it is happening at this facility called Large Hadron Collider, and we should know about that. So I have talked about fundamental particles in previous classes. I do remember that, by the way. So I do remember that part, that we did discuss about fundamental particles. Maybe they have given a picture of standard model, don't worry. I've talked about this particular model in previous classes, standard model of particle physics. That in particle physics, one of the most important question we try to ask here is, or we ask here is, that what are we fundamentally made of, and how are those particles interacting? We talked about that everything is made of 12 particles divided into two groups. One group is called lepton, another group is called quark. And these leptons and quarks, they interact via three interactions: strong, weak, and electromagnetic interaction. And that interaction is mediated by group of particles, we call them bosons. For example, photon mediates electromagnetic interaction, gluon strong interaction, and W and Z boson that mediates weak interaction. This part we already have discussed in the context of neutrinos. We have talked about neutrinos, what they are, and why we should know about neutrino research. But one of the most important particle, that center में जो आपको दिख रहा है, that particle is called Higgs boson, the so-called God particle, a name which was given to some people. Higgs boson का जो theory है, that was developed by a scientist called Peter Higgs when he was a PhD student. In fact, he had just completed his doctorate, completed his PhD, and one of his earlier papers was that he was interested in answering a question that why these fundamental particles have different mass. Some of them are massless, some of them are heavy, right? So why is it so? So that was a mystery, that fundamental particles, they do have mass and they do have different mass. So Peter Higgs theorized that, he imagined that this entire universe is filled with a field which is named after him. It is called Higgs field. And Higgs field, as particles interact with Higgs field, or as they travel in the Higgs field, they face a resistance, and the more resistance they face, that resistance actually is mass, basically. So the more resistance they face, that is manifested as mass. And particles who do not feel any resistance, they do not have any mass. They are massless particle. And we can imagine it like this. So imagine entire universe filled with ink, and think of a tissue paper, think of a newspaper, and think of a plastic. So a tissue paper traveling through this ink is going to absorb a lot of ink. A newspaper will absorb less ink, and plastic will absorb no ink. So if you want to imagine something like this, of course it is happening at a very fundamental scale. We do not have any perspective here, again, to imagine this. It is completely mathematical. We have no perspective whatsoever. That the imagination part, we do not have any perspective. But if you do want to imagine it, you can think of it like this. So various particles, as they travel through Higgs field, they face a resistance, and that resistance is manifested into mass. So this was the concept. But then how do we know? Remember, science is not about theory, science is about what can be proved. So how do we prove that this concept is actually true? So Peter Higgs had an idea for that also. The idea involved that जो Higgs field है, even though it is a relatively stable field, but sometimes there will be excitations in this field, and that excitation will lead to production of a particle, and that particle is again named after him, after Peter Higgs himself, and that particle is called Higgs boson. And he did all of the mathematical calculation in 1960s itself, that if Higgs boson does exist, then what will be the mass of Higgs boson, or what will be its spin, or what will be its charge. All of the properties he had theoretically derived, that this will be Higgs boson. If Higgs field is real, if it does exist, then there should be Higgs boson. And if Higgs boson does exist, then these are the properties of Higgs boson. All of that he did in 1960s itself. And this was initially, people did not think a lot about his theory. He was quite young. But later, as more and more people got to know about his mathematical calculation, they were very confident that he's onto something. His mathematics was ingenious. Whatever he was claiming, that perfectly aligned with already existing knowledge. So a lot of experimental setup now were made to know about this Higgs boson, that maybe let's try to find it out if it does exist. And despite so many experimental setups, nobody found it. And that is why the concept of God particle emerged, that a particle which seemed to answer one of the most fundamental question about the reality of nature, but nobody had seen it. God is also a concept very similar to that. So that is why the word God particle became very famous. But then there is a very famous setup which we all should know about it. This remains in news a lot, and this was recently particularly in news. This setup situated in Switzerland, a 27-kilometer tunnel. And in this 27-kilometer tunnel, you have superconducting magnets. With the help of those superconducting magnets and the devices which can accelerate charged particles, particularly proton particles. So inside these tunnels which you see, for example, this will be a cross-sectional view of the tunnel. You have the beam of electrons in two opposite directions. First, this two beam of electrons will be accelerated very close to speed of light. Now, protons can never travel with speed of light, but they can come very close to speed of light. The goal here will be to achieve as close to about 0.9999 times speed of light. And then when they have enough speed, then in a very thin area, like an area smaller than in fact our hair, this two beam of, because remember protons are very small particles, so these two beam of protons are then collided at very high energy. So these protons are traveling with almost with speed of light. Again, remember they can never travel with speed of light, but almost very close to speed of light, and then they are collided. Now because of this collision at such high energy, a lot of particles will be produced, will be destroyed. And there are detectors in this chamber where this collision happens. Those detectors record the properties, the changes which have happened, and that data is then analyzed on very powerful computers. And then Large Hadron Collider, and by the way, jo pura setup hai, this comes under an organization called Center for European Nuclear Research, CERN, more popularly called CERN, CERN. So in 2012, CERN announced, CERN का जो पूरा सेटअप है लार्ज हेड्रॉन कोलाइडर, लार्ज हेड्रॉन कोलाइडर के खुद के अपने अलग अलग एक्सपेरिमेंटल प्लेसेस हैं. जैसे यू हैव दिस detector called Atlas detector or an ALICE detector or LHCb detector. So there are various detectors within Large Hadron Collider. And CERN then announced in 2012 that without a doubt they have discovered Higgs boson. And Peter Higgs was given Nobel Prize in Physics in 2013 for that. Right. And Peter Higgs, by the way, has just died. So he died like 2 months ago. So because of that also, I think this is a very important topic. This was a global news, all newspapers. Peter Higgs is a very popular name. Like Higgs boson is a very popular concept in physics, and Peter Higgs himself is a very popular name. So his death was covered by almost every newspaper on the front pages. So I do think understanding about Higgs boson, knowing about Large Hadron Collider, this 27-kilometer setup located in Switzerland under an organization called CERN. India is an associate member, not a full member, but India is an associate member of this facility. All of that information we should know here. We should also know that as we speak, Large Hadron Collider has a proposal that they want to make a bigger collider. They want to make a collider of not 27 kilometer, but I think 100 or 200 kilometer collider they want to make, where they can accelerate protons even more, and the collision can occur at even higher energy. And maybe that will perhaps tell us more about some of the fundamental processes which happen at the most fundamental level, even at the level of quark or even smaller than that. If something smaller than that exists, maybe we'll get to know about that. So standard model does not claim that we have found all of the realities of nature. Standard model has a lot of limitations, and the purpose of Large Hadron Collider here is that maybe let's try to find new physics, maybe the type of physics which we do not even know exist. Let's try to find that. So with that in mind, you have this circular collider which is in proposal, a much bigger collider under that will also operate under CERN. Now this topic is in news because in 2012 it was discovered, Higgs boson was discovered. But because Higgs boson is a very unstable particle, the moment it gets produced, it also gets decayed. So what happens to it? What it decays into? So this topic is in news because we now have information about what it decays into. That's it. That topic is not important, frankly, but the concept of Higgs boson, Higgs field, Large Hadron Collider, CERN, all of that is an important topic for examination, right? A few more things, like just one or two more things I would add here. I would add here in this entire concept that there is a big misconception that Higgs boson gives mass to fundamental particles. Like you'll come across this term a lot, that Higgs boson is responsible for the mass of fundamental particle. Now that is not entirely true. In fact, that is not at all true. What will be true is that it is Higgs field which is responsible for the mass, and Higgs boson is just a confirmation that Higgs field exists. I do not think that UPSC will go into such nitty-gritties, but if in examination, if there is a question, if there is a statement that Higgs boson allows us to understand why fundamental particles have mass, then that will be a correct statement. It will not be an incorrect statement. But the second myth which people have here is that people think that our mass is also because of Higgs particle, that it is fundamentally because of Higgs mechanism. Now Higgs mechanism only answers the mass of fundamental particles. After that, when those particles come together, when they form atoms and molecules and matter, for that we do not need Higgs field. For that we can use Einstein's equation, because the particles such as quarks and leptons, जैसे electron हो गया, quark हो गया, they have very high speed. They often inside nucleus also, or inside atoms also, they travel with very close to speed of light, and because of that they have a lot of energy. And remember that Einstein's mass energy equivalence equation, E is equal to mc squared. So that m here becomes E by c square, and E is basically energy of fundamental particles. So Higgs boson or Higgs field only explains a very small fraction of mass, and that too only of elementary particles. But as those elementary particles come together because of electromagnetism, because of strong or weak, and as they form atoms and molecules and matter, now that mass is because of Einstein's mass energy equivalence, E by c square. So this is also a common myth that all of our mass or matter's mass is essentially because of Higgs mechanism only, which is not true. So I think this much information we should know about this topic. UPSC has asked questions in previous years also, and I do think that they can ask questions in future also. If you have any doubt here, you can ask questions. Good then. Two things: chiral Bose liquid. Chiral Bose liquid is a state of matter which exists at very, very low temperature, different from Bose-Einstein condensate. So we have studied about solid, liquid, gas, three states of matter. All of us know, feel. Then we know about plasma also. Plasma exists at very high temperature, uh, fourth state of matter. I will be talking about Bose-Einstein condensate. आपके updated material में डॉक्टर सत्येंद्र नाथ बोस के बारे में discussion है. So I'll be talking about Bose-Einstein condensate. Now that is a more important topic compared to chiral Bose liquid. So Bose-Einstein condensate was hypothesized by Einstein and Dr. Satyendra Nath Bose, which was confirmed in 1990s. Fifth state of matter. Very similar to, but not exactly the same. That at low temperature, at very low temperature, things become quite weird. Physics is very clear when we analyze things which occurs around us. Except few things, physics is very clear. Now, except those few things include very small things, very fast things, very cold things. So whenever things become, and very huge things. So whenever things become very small, such as atoms or elementary particles, whenever things become very huge, such as a supermassive black hole, whenever things become very fast, when objects start traveling with very close to speed of light, and whenever things become very cold, when objects exist at the temperature of minus 270, minus 272 degrees Celsius, then our understanding is questioned here. Our understanding is actually quite limited. We do have understanding, but a lot of things we do not understand really well. So at low temperature, lot of interesting phenomena happens. One of that phenomena is a new state of matter with its unique property called chiral Bose liquid. I will not remember anything else from this topic except this one, that it is a state of matter which exists at very, very low temperature. That's it. I will only, and जो Bose यहाँ पे word है again, that is because of Dr. Satyendra Nath Bose. Nanophotonic electron accelerator. This was not covered a lot into newspapers, but I do think it is quite a remarkable discovery. As I just told you about Large Hadron Collider, a 27-kilometer tunnel, or even a future collider, 100-kilometer tunnel, which aims to collide proton beams at very, very high speed. So nanophotonic electron accelerator hai, that is actually quite a small device. Let me show you this also. Very small device within its own very small vacuum chamber, where the goal is to create electron beams at very high speed. The purpose here is that because electrons are such small particles, that if we can accelerate them enough within this vacuum chamber, then these electrons now can be utilized to target a very specific cell or tissue inside our body. तो इसका जो सबसे important application होगा वो medical cases में होगा. That we are talking about electrons, particles, they are around us, we cannot see them. So electrons which can enter at a very specific cells and tissues, and they can be quite helpful, particularly let's say in tumor treatment, in cancer treatment. So it's a very small particle, miniaturized particle accelerator with this fundamental objective of accelerating electrons with very high speed. And the goal here is that let's use that energy of the electron to destroy cancerous cell. So medical applications. That's it. I will remember one or two things about nanophotonic electron accelerator. Superconductivity is an evergreen topic. Very I'm still get surprised that अभी तक कोई भी क्वेश्चन नहीं पूछा यूपीएससी ने. हो सकता है 2008-9 में पूछा हो मेंस में 5 marks or 10 marks में. But in last 10-12 years, they have not asked a single question on this concept. But this is one of the most popular areas of research all across the world, superconductivity. And to appreciate superconductivity, it is actually quite simple, because all of us have studied Ohm's law. All of us remember that relation V is equal to IR, right? That if in an electrical circuit there is some resistance, then current gets reduced by R times, where R is resistance. I, electrical current, is equal to applied voltage divided by R. The one of the consequences of this resistance here will be loss of energy. We have talked about that also, that whatever energy you supply into a circuit, not all of that energy you will be able to utilize. Some energy will be lost as heat energy. We have read about that. In fact, we try to use that heat energy. जब हम बहुत बार क्या करते हैं, हम इलेक्ट्रिक जो रॉड यूज करते हैं पानी गर्म करने के लिए, that is an application of that high resistance which produces a lot of heat energy. So we have studied about it. We have studied about Ohm's law. Bigger the resistance, higher the resistance, less will be the transmission of electrical energy. There will always be some losses in the electrical energy. So to appreciate superconductivity, that's very quite simple. Resistance becomes zero. We are talking about matter, we are talking about materials, जिनके अंदर का जो resistance है वो zero हो जाए. Turns out this resistance becomes zero only at very, very low temperature. Why does it become at very low temperature? We actually have a very good explanation for that. That explanation does require understanding of particle physics. I will not go into detail of that, but I will tell you about a keyword here. I do think that maybe that keyword you can remember. That keyword is called Cooper pair of electrons, named after the scientist who first discovered it. So there was a scientist, Dr. Cooper. He discovered, or he theorized, that at very low temperature, very close to absolute zero, again we are talking about minus 270, minus 272 degrees Celsius. So 1 Kelvin, 2 Kelvin, I'm talking about in this range of temperature, two electrons work like one particle. Now two electrons, electron is a fermion with half spin, but two electrons together start acting as a boson. So in the previous topic, when I was talking about Higgs boson decay, I talked about two group of particles which makes up everything, leptons and quarks. Leptons and quarks, they follow a very interesting law, that how they are going to arrange themselves. That law is called Fermi-Dirac statistics. We have learnt about that when we learnt to write electronic configuration. Remember your class 9th, 10th classes of chemistry? It was as simple as writing the electronic configuration of, let's say, lithium. This was 1s2, 2s1. Simple. So electrons have this way of arranging in different shells, and in one particular orbit, in one particular orbital, you can only have maximum of 2 electrons. You have studied that in your class 9th, 10th classes also. Of course, जैसे if you go to, let's say, for example, sodium. Sodium has 11 electrons. So p orbital has 6, but if you have studied again chemistry in class 11th and 12th, then you will remember that this p is actually px, py, and pz. That p is not one orbital, but there are 3 orbitals, and all 3 orbitals have 2 electrons here. So in one energy state, I can only have 2 electrons, not more than 2. This particular distribution law was discovered by a scientist called Fermi and Dirac. So this law is called Fermi-Dirac statistics. And the leptons and quarks, which I mentioned earlier, they follow Fermi-Dirac statistics. All leptons and quarks, they will follow a rule that in one energy state, only 2 particles can stay. A very simple version of Fermi-Dirac statistics we have studied in our school days. This is what it is. So all the particles which follow Fermi-Dirac statistics, those particles are called fermions, named after the scientist Fermi. Electron is a fermion. Electron follows Fermi-Dirac statistics. But then these particles interact via bosons. We talked about that. So the reason we call them bosons, boson comes after Dr. Satyendranath Bose. They follow Bose-Einstein statistics. Bose-Einstein statistics is different from Fermi-Dirac statistics. So you have also fundamental particles which follow Bose-Einstein statistics, and hence the name bosons. The best famous example of boson is photon, जो light का जो particle है, That is the most famous boson. So at very low temperature, two electrons start acting like one particle. And two electrons which individually are fermions, but when they start acting like one particle, hence the word Cooper pair, they now start behaving like boson. And when they become boson, they do not feel any resistance from the lattice. So think of a metal. Metal के अपने atoms हैं, बड़ा बढ़िया arrangement है atoms का. And because of this arrangement, electrons feel this इलेक्ट्रॉन हमेशा कहीं ना कहीं से किसी से टकरा जाएगा, किसी और से टकरा जाएगा. सो इलेक्ट्रॉन का जो फ्लो है दैट विल ऑलवेज बी ऑब्स्ट्रक्टेड, एंड दैट ऑब्स्ट्रक्शन लीड्स टू व्हाट वी कॉल resistance. But in case of when the electrons start behaving like boson as a Cooper pair, then they do not feel any resistance, and now they can travel in the lattice completely undisturbed. For this, Dr. Cooper was given Nobel Prize in Physics for the explanation of superconductivity. So superconductivity is a phenomena where resistance becomes zero. So that Ohm's law which we have studied in our school days, that if I apply a voltage V, current I and resistance R, then I gets reduced by R times. Again, this is not a fundamental law. It is simply a statement about conservation of energy, that I applied energy with V voltage, but some energy is lost because of resistance here as heat energy. So it is fundamentally a statement of conservation of energy, not a fundamental law. What if resistance becomes zero? If I have electric current, that electric current can now be transported. That electrical energy can be transported from one location to another location without a single iota of loss. So I will have zero loss of energy inside superconductor. तो superconductors, however, जो superconductivity खुद में जो है quantum phenomena है. Superconductivity cannot be explained by classical laws of physics. That why will resistance become zero? For that we need to apply quantum mechanics, and turns out this resistance becomes zero at very, very low temperature. But there is one more thing happens, and that is why I had highlighted the picture which is given in your material. That when you, in this picture, you have a normal conductor, not a superconductor, and there is some magnetic field that this conductor, imagine that this is a conductor, and in this room there is some magnetic field. I have a, let's say, bar magnet. This is a bar magnet, this is a conductor. Because of this bar magnet, there is some magnetic field. I keep a conductor nearby, nothing happens, not a lot happens. This magnetic field can easily cross inside this conductor. But now let's replace this conductor with superconductor. Now this is a superconductor, and this superconductor cannot allow, and in fact will not allow, any magnetic field to exist inside it. It will produce its own magnetic field in a way that the net magnetic field inside superconductor will always and always be zero. That is another amazing feature about superconductor, that not only resistance is zero, but even magnetic field inside superconductor, magnetic field is often represented with B, that also becomes zero. This was discovered by a scientist called Meissner, hence the name Meissner effect is used for it. And this also has a lot of applications, by the way. The fact that superconductors have such amazing magnetic phenomena, or magnetic property associated with them, it has lots of application. The most famous one, which is given in your updated science and technology material, magnetic levitation technology, maglev technology. And there are some really good videos available on YouTube which I can show. In this video, what this person has done is he has taken a conductor and magnets, and then he has cooled down this conductor with the help of liquid nitrogen very close to minus 200 degrees Celsius. And he makes all this arrangement. He makes a magnetic track first. Now this is a superconductor, sorry, this is a conductor as of now, but on this conductor he is going to pour liquid nitrogen. Liquid nitrogen has a temperature of very close to minus 200 degrees Celsius. and because of that the temperature has become again here, and now it's simply going to suspend there. And why it is suspending there? Because it repels the magnetism which already is because of this magnetic track. It cannot allow a magnetic field to exist inside it, so it is going to repel that magnetic field, and the net magnetic field here will be zero, so it will look like floating now. So there is a gravitational force which will try to pull it down, the earth's gravitational force, but because of the magnetic repulsion, that magnetic repulsion will balance that gravitational force, and the moment you keep it here, it will just stay there. So this is actually a practical demonstration of Meissner effect. And now you can have this floating superconductor on this magnetic track. So this particular technology at a very miniaturized small scale which you saw, this is what we call magnetic levitation. Levitation का मतलब होता है float करना, that you are floating in the air. In this case you are using magnetic repulsion to float in the air. So superconductivity के बारे में दो तीन चीजें जो हमको पक्के से clear होना चाहिए for examination. That superconductivity के जो दो properties हैं, first that resistance becomes zero, second Meissner effect, that magnetic field inside superconductor becomes zero. Superconductors will have its own magnetic field in a way that the net magnetic field inside it will be zero, and this phenomena is called Meissner effect. First thing. Second thing, superconductivity at very low temperature was explained by in fact three scientists. I have forgotten their full name. I remember the name Cooper, but the theory which explains superconductivity is called BCS theory. So BCS theory mein jo C hai, that is Cooper, and Cooper was the main scientist who talked about the concept of Cooper pair, that how two electrons start behaving like one particle here, and they start acting like a boson. Now the third thing which you should know here is that superconductors have lot of applications, and both of that, the fact that it has zero resistance, has applications in energy transportation. Imagine that if we can have superconductor, zero loss of energy, we can transfer energy from one location to another with zero loss of energy. Now that is in itself tremendously useful. Superconductors at such low temperature, I have talked about quantum computing in previous classes. One of the most famous qubits, one of the most famous candidate of designing a quantum bit or qubit is actually superconductors or superconducting mechanism. जो Meissner effect का जो application है, one of the most important application of Meissner effect is in maglev technology, which I already talked about, but it has many more applications because it is sensitive to even very small magnetic field. ऐसा नहीं है that magnetic field जब बहुत strong होगा तब ये repulsion दिखाएगा. Even if magnetic field is very small, it is sensitive. What does that mean? That earth का जो magnetism है, it's not all the places it is not the same, and a superconducting sensor will allow us to measure even if the magnetic change is happening with a very, very minor value. So that is another benefit of superconductivity. So both the electrical property and magnetic properties allows lots of application of superconductor in various areas. And then last thing which you should know, which is not important for examination, but let me give you the context of the news, because ये पहली बार news नहीं है और ये आखिरी बार भी नहीं होगा. That lot of people in past, in fact last 20 years, there has been at least 10 to 20 times there have been claims that some group of scientists, they have developed a superconductor at room temperature. So the biggest challenge in attaining Bardeen-Cooper-Schrieffer theory, thank you, BCS theory. So anyways, the biggest challenge in attaining superconductivity is low temperature. Low temperature, you literally have to create conditions where temperature goes into minus 200, minus 250 degrees Celsius. That in itself is very difficult. So in our day-to-day life, it is not possible. But in sophisticated applications, we do use superconductors, goes without saying. अब ये जो claim है that materials exhibiting superconductivity at room temperature, think of superconductivity at even 0 degrees Celsius, because 0 degrees Celsius will be room temperature in many polar areas, and that will also be quite amazing. So there have been many claims in the past where scientists have mentioned that how they have attained room temperature superconductivity, and all of those claims till now have been falsified, that this was not accurate data, or this was not repeated, this was not be able to repeat it by somebody else, so clearly they are not talking a lot of sense here. And a long list of news. One more news here is that some scientists from South Korea announced that they have developed a material LK99 at room temperature superconductor, and that was also turned to be a false news. So ये उतना important नहीं है, but superconductivity खुद में एक important topic है. What it is and what are the possible applications of it and what are the challenges in it. The biggest challenge, of course, is that very low temperature requirement. Rare earth elements, we should know about this concept, simple basic concept of chemistry. The topic is in news because in Andhra Pradesh Anantapur district, large deposits of 15 rare earth elements have been found. That does not mean that it is economically feasible. So this is initial assessment. The next level of assessment will be that how feasible it is. What are the local ecological conditions? How economic it will be. So a lot of parameters will decide about how much this rare earth element will be actually extractable and beneficial. And that will take some time. But that in itself is a good news that in Anantapur district we found rare earth elements. So rare earth elements, as the name suggests, they are rare. Uh, you have this silvery white soft heavy metals that occurred together in periodic table. In fact, I can show you. So these two metals which you see, scandium, yttrium, then this lanthanide and this entire lanthanized series which you see, all of that collectively together is called rare earth elements. Why they are such a big deal? Because the most important industries, electronics industry, the first thing, defense, material sciences, you have lot of applications of rare earth element. And uh, China is quite strategically placed here. China has been quite smart into how it is playing its geopolitical game. So China में reserve तो खुद में है ही, but जो बाकी जगह भी जो reserve, and by the way, China is not doing this just in case of rare earth element, but also in case of lithium. That China had some lithium, some rare earth element. They actually have quite huge amount of rare earth element. But even where it does not have reserve, and wherever the reserve has, China is placed so suitably in the global supply chain that the final processing occurs via China, and they have been doing that for last few decades now. So they have been playing this long game about the most sophisticated industries and how China will play a key role there. So any such type of news where we have found reserves is a great news. So they have applications in many areas and all most sophisticated technologies. So in modern material science is one of the most underrated or one of the least talked about branches of technology, but material science is perhaps one of the most important branch of technology. This mobile phone is 90% material science and 10% its electronics part. But think of each and every part of it, that इसके जो transistors हैं वो किस चीज से बनेंगे, that essentially is material science. इसका जो display होगा वो किस चीज का बनेगा, that is material science, right? So material science is one of the most important thing, चाहे वो defense हो, rockets हो, electronics हो, and जो rare earth elements हैं, they play a very important role in that. Another very important mineral element is vanadium. Vanadium का जो सबसे famous ore है, सबसे जो famous mineral है, this mineral is called titanomagnetite. So in one line I will remember this. Titanomagnetite is an essential source of vanadium, and vanadium also has a lot of applications. This much information is not required. Directly go to the application part. It has applications in making nuclear reactors, in certain type of medicine, in healthcare. It is also used as catalyst, and it has applications in aviation industry. So just focus, go on the application part, and the topic, the reason why this topic is in news, that in Gulf of Khambat we have found vanadium reserve. Hopefully this will be extractable and this will be beneficial. So small topic, but nonetheless we should know about this. Vanadium के features क्या हैं, applications क्या हैं, that's it. The next topic, I think this is this the last? No, not the last topic. Lab grown diamonds. Somehow there is a misconception that this is a fake diamond. It's not a fake diamond. That is the first thing which should be we should be very clear about lab grown diamonds. Fake diamond मिलते हैं market में, बिल्कुल मिलता है, but lab grown diamond is not a fake diamond. We know the mechanism by which diamond gets produced in the earth's crust. We need very high temperature and very high pressure, but fundamentally it is arrangement of carbon atoms in a very specific type of structure, in a very specific type of atomic arrangement of carbon atoms lead to what we call diamond. And diamond then उसका जो पूरा crystal structure है वो इस तरीके से होगा that it will allow light to undergo total internal reflection. It will become very shine. It becomes very strong, of course. That is another amazing feature of diamond. जो पूरा diamond industry है ये हमारे जो वही this is one of the best example of human desires, that human desires are unlimited. तो जो पूरा diamond industry और जिस तरीके से diamond को गिफ्ट से या मैरिजेज से जो पूरा रिलेट करके रखा हुआ है, बिना डायमंड के शादी कंप्लीट नहीं होगी, सॉर्ट ऑफ एंगेजमेंट नहीं हो सकता. सो ऑल ऑफ दैट लीड्स टू वेरी प्रॉस्परस इंडस्ट्रीज एंड ऑल ऑफ दैट ऑल्सो लीड टू लॉट ऑफ cases of human rights violation which particularly occur in African nations. Lab grown diamond, it aims to make diamond in a lab, as the name suggests, at very high temperature and very high pressure. So it will start with graphite, because remember graphite is also an allotrope of carbon. So it will start with graphite, and in a very specific setup there are processes where atom by atom we can deposit carbon in a specific lattice structure. The most famous method, for example, is this method called chemical vapor deposition. The chemical vapor deposition is used in many areas, but one of that will be here in making lab grown diamonds. This high temperature, high pressure starting from graphite, and we can make lab grown diamonds. So they are actually actual diamonds. So lab grown diamond is not a fake diamond per se. They are actual diamonds. There are differences because we haven't invested into war prone areas where mining, human rights violation occur and diamond is produced, which is a risky business. Diamond is very, very expensive. Lab grown diamonds ka cost bahut kam hoga. They have been produced into a lab. No human rights violation, no mining related issues, no war-torn areas. In a lab it has been made, and India is in fact one of the key countries where lab-grown diamond is actually produced. Surat particularly बहुत बड़ा famous center है जहाँ पे lab-grown diamond बनते हैं. So affordable, little to no environmental damage, guaranteed origins and trackable source, natural diamond, impurities, expensive, water pollution, comes from conflicted region, all of those things. Graphene, I may have talked about graphene in previous classes. Graphene is this another allotrope of carbon, but a two-dimensional material. It's like carbon atoms arranged on a plane here. So think of carbon atoms, but arranged just in a plane, does not have any thickness. Carbon atoms, a two-dimensional material of carbon. So we cannot imagine that thickness. That thickness will exist in nanometer, even less than nanometer. So this material is called graphene, which has some amazing properties. It is quite tough, very good conductor of heat and electricity. Density is not very high. Is very, very chemically unreactive. So that is another good feature of graphene. And one new property which people have discovered is called giant magnetoresistance. I don't think, frankly, this topic is very important. Giant magnetoresistance is a property where we use atomic material, such as in this case graphene, between two conductors, and we just change the orientation of the magnetic field. In fact, let me show you with a picture that will become much more clear. Yeah, this is more than enough. So you have a very thin layer of material, often a nano layer of material between two materials. These two materials which you see in blue, they are magnetic materials. So this material between, which is shown in orange here, it is sandwiched between same type of magnetic material. If the magnetic field is in the same direction, this material will exhibit some electrical resistance. And again, the same material, the only simple change which you do here is that you reverse the field of magnetic, you reverse the direction of magnetic field. So in this particular case, both the magnetic field in the same direction. In the second case, magnetic field in upward direction, magnetic field in downward direction, and suddenly this material gains huge electrical resistance. In the first case, the resistance was very less. In the second case, resistance becomes really huge. It is a quantum phenomena, cannot be explained by simple laws of physics. It essentially involves quantum mechanics. That's not important. What is important is what this property is, giant magnetoresistance. What does that mean? We are talking about same material sandwiched between two magnetic materials, and just by changing the direction of magnetic field, we can change electrical resistance. This property is called giant magnetoresistance, and graphene exhibits giant magnetoresistance. Yes, we can. In fact, carbon nanotubes are made from graphene. Carbon nanotubes are made of graphene. Right? So carbon nanotubes essentially are the cylindrical tube made out of graphene. Okay? Sorry? They are nanostructure. Again, carbon nanotube, nano word hai wahan pe. So carbon nanotubes are very important type of nanomaterials known for a lot of properties of graphene, but also depending upon how you fold them, they can acquire new type of properties. Okay. Radiometric dating. Radiometric dating essentially utilizes, this topic was in news a lot. It has been news a lot, by the way. This topic is in news that we can use calcium 41 for radiometric dating. I'm not very sure how this question will be asked in prelims examination, but I will still explain the concept of carbon dating जैसे हम सबने पढ़ रखा है, that carbon dating जो है. So let's try to understand that how does this function. Again, I have no access perspective that how this will be asked by UPSC, particularly in prelims. In mains, I expect a question, that explanation part. So carbon 14 dating जो है, that works on certain assumptions, but those assumptions are valid assumptions, and we have very good reasons to think that why they are valid assumptions. Carbon dating essentially works upon the fact that atmospheric, जो पूरा अर्थ का atmosphere है, all the time it is bombarded by lot of cosmic particles. There are many stars and galaxies and particles which may have started their travel many years ago, and all the time Earth's outer atmosphere is bombarded with neutrons. That bombardment converts nitrogen. Nitrogen is one of the most abundant element in the universe, into carbon 14. So the first thing which happens here is that carbon 14 is produced in the atmosphere because of bombardment of neutrons on nitrogen already present in the atmosphere. So nitrogen 14 is a very stable nucleus. This becomes carbon 14 because of bombardment of neutrons. Now what happens that this carbon 14 is a radioactive element. This carbon 14 emits beta particle, and then it converts into nitrogen 14. It converts back into nitrogen 14 by emitting a particle which is called beta particle, which is nothing but electron essentially. So by emitting electron, it converts back to nitrogen, and this particular process, it is a type of radioactive reaction which is called beta decay. Now all radioactivity follows a very simple rule, that radioactive substance, whenever it emits alpha or beta particle, it will have a half-life. What does the term half-life mean? That I start any sample where my number was n, after some time t, half of the sample became something else. So for example, let's say I started x emitted either alpha or beta. Now beta is nothing but electron, alpha is nothing but helium. So whatever, alpha or beta, and it became y. So I started with atom x, that atom x became y. Let's say when I started this calculation, the total number of x atoms, that was n, and after every time t, half of x is converting into y. So in time t, half of x has converted into y, so other half has left here. So I have only n by 2x which is left. If this relationship follows a linear decay, that if I plot it here, जैसे मान लो this is n and this is t, when I started my calculation, I had this total number here, and it became n by 2. And if it follows a linear decay, in next time t it is going to become 0. So in time t it became half, in next time t it is going to become 0. But this is not what happens. What happens is that in next time t, half further only decays. So out of n by 2, half further decays. So n by 4 still will be left. Another half will decay. N by 8 will be left. N by 16, n by 32. So in a way, it never comes close to 0, or it comes close to 0 but never becomes 0. So actual plot is something like this, that it comes very close to 0 but never becomes 0 per se. All radioactive sample, they follow this fundamental property that they decay, half of the sample decays into something else in a specific time, and that specific time is called half-life. And for every radioactive element, the half-life will be different. जैसे कार्बन 14 का जो half-life है, करीब करीब 5800 years का है. If you want to further approximate it, you can think of this as a 6000 years. Exact value is some 5730 years. I can approximate that to be 5800 years. So carbon 14 decays into nitrogen, and whatever carbon 14 I start with, every 6000 year, I only will have half of it left. But how do we use that in dating of fossil, by the way? कोई भी fossil हमको मिला है, and how do we know that how old this is? So now this involves a lot of assumptions. The assumption here is that when plants do photosynthesis, you have a lot of carbon dioxide in the atmosphere, but carbon dioxide will be carbon-12 carbon dioxide, but some of the carbon dioxide will also be carbon-14 carbon dioxide, because जो chemical property है, that does not depend upon your number of neutrons. That only and only depends upon number of electrons. ये सबने पढ़ रखा है, that chemical properties essentially is dependent upon the valence electrons. So outermost shell में जो electrons हैं, they will decide कि आपका chemical property क्या है. So carbon 12 हो या 14 हो, दोनों में ही 6 प्रोटॉन है, 6 इलेक्ट्रॉन है. In the second one I have 8 neutrons. So chemical property दोनों का same है. So if carbon 12 can react with oxygen and make carbon dioxide, यहाँ पे C12 नहीं है, कार्बन के 12 एटम नहीं है, C12 का मतलब यहाँ पे, in fact let me change this so that there is no confusion. That you have some carbon dioxide which is made of carbon 12 and some carbon dioxide which is made of carbon 14. The amount of carbon 12 and carbon 14 in the atmosphere does not change a lot, or particularly their relative concentration does not change a lot. So whatever ratio I start with, that let's say I have carbon 14 by carbon 12, this ratio is n. That n will be a very small value because carbon 14 is very, very small compared to carbon 12. But when plants do photosynthesis, they capture carbon dioxide. So they are going to not distinguish between carbon 14 and carbon 12. So they will capture both carbon 14 and carbon 12. So the same atmospheric ratio is also found in plants. And then all living organisms, they eat plants or they decompose plants. So the same atmospheric ratio is found in all living organisms. So if I take a sample, just let's say some skin, my skin sample is removed and is analyzed, that after all of us are made of biomolecules. Apart from 70% water, अगर हम उसको हटा दें, then rest are biomolecules, and all biomolecules contain carbon. So whatever carbon 14, carbon 12 ratio is found in atmosphere, the same ratio is also found in all living organisms, starting with plants but also in animals. So as long as I am alive, the same ratio will be found throughout my life. But when I die, then carbon 14, so a lot of course, flesh will decompose, go away. Some can survive for few thousand years, particularly bones can survive for few thousand years. And bones will also have carbon. Now carbon 12, that is not radioactive, that will remain in the same concentration. But carbon 14 will keep on declining because every 6000 year, half of the carbon 14 is converting into nitrogen. So all I have to do now here is that whenever I collect a fossil sample, then I just have to see that what is the current ratio. Maybe it is some n by m ratio. That ideally when something was alive, the ratio was n. Right now the ratio is n by m. Now ये n से n by m कितना time लगेगा ये हम आराम से calculate कर सकते हैं. So all I need to do whenever I collect a fossil and I need to know how old this is, I just have to calculate that what is the ratio of carbon 14 and carbon 12. And then I already know that when this fossil or whatever was alive on this fossil, what should have been the actual carbon 14 carbon 12 ratio and how much time it will take for this carbon ratio to decline. So n became n by 2 in 6000 year, it became n by 4 in 12,000 year, it became n by 8 in 8,000 year. So every 6000 year n started becoming half and half and half and half. I just have to calculate the current n by whatever it is, and then I know how old a particular fossil is. So this is how carbon dating works, that we use the concept of radioactivity, we use the concept of half-life. But carbon 14 has a half-life only of about 5800 years. And यहाँ तक तो चलो फिर भी ठीक था. अगर ये n by, जैसे मान लो I plot this decline of carbon 14, तो इस पूरे एरिया में जो डिक्लाइन है अगर यहाँ तक है फिर तो ठीक है. बट अगर हम यहाँ पे जब हम आना शुरू हो जाएंगे तो ये डिफरेंस बहुत ज़्यादा नहीं है. So it will start giving you errors now that you have a sample, fossil sample, let's say which is 100,000 year. वो 50,000 साल पुराना नहीं है, वो 1 लाख साल पुराना है, वो 5 लाख साल पुराना है. Then in that case carbon 14 is not a very reliable source. And that is why this topic is in news, that let's use calcium 41. Now calcium का जो सबसे famous element है, that is calcium 40. But calcium 41 is another isotope of calcium, and calcium is essential part of our bones. So whenever we look at bones, then bones will have calcium, and calcium will also same logic. We can apply the same logic, that what should have been the ideal ratio of calcium and what is the actual ratio of calcium which we have found in a sample right now. But the good thing about calcium is that calcium 41 has a half-life of about, if I'm not mistaken, about 1 lakh years. So 100,000 years. Little bit less than 100,000 years, but it is close to 100,000 years, while carbon 14 has half-life of only 6,000 years. So if I collect a bone, for example, and even if that bone is few 100,000 years, I can determine that how old that particular fossil is. So this is how radiometric dating, चाहे carbon 14 हो, चाहे calcium 41 हो, how this functions. In some other cases we use uranium also, and we use some other things also. So carbon 14 is not the only thing which we use. Carbon 14 gives you better result, but only for fossil which is not very old. Once the fossil is very old, then carbon 14 is not actually the right way forward. We'll have to look for other isotopes, and we'll have to look for other type of dating techniques. However, there will be error there. जो other dating techniques होंगे वहाँ पे margin of error ज़्यादा होगा. So this is about radiometric dating, which is given in your material. Draft National Strategy for Robotics. That is hybrid nanoparticles. Simply we are talking about nanoparticles which are made of 2 or more than 2 things. Sorry? Calcium 41 divided by calcium 40. जो कैल्शियम का जो सबसे प्रेवलेंट, कैल्शियम का एटॉमिक मास क्या होता है 40 या 39? 40 होता है ना. तो जो सबसे प्रेवलेंट फॉर्म ऑफ कैल्शियम है, सो कैल्शियम 41 डिवाइडेड बाय कैल्शियम 40, ये रेशियो क्या होगा? Calcium 41 is also produced because of bombardments, cosmic bombardments. It is not found naturally as such on Earth. So it is found naturally, but it is a result of cosmic bombardment. Same as carbon 14. So we take the ratio of calcium 41 divided by calcium 40. The same way we took the ratio of carbon 14 divided by carbon 12. Hybrid nanoparticle simply means 2 or more than nanoparticles together. And nanoparticles के बहुत सारे applications, I talked about that in previous class. ये draft policy की कोई ज़रूरत नहीं है robotics की. White phosphorus, there was a news that Israel may have used it. White phosphorus is flammable, बहुत जल्दी आग लगता है इसमें, and as a weapon it can be used. Tantalum, this is interesting. Tantalum has one of the, again another elements which has applications in semiconductor industry. Electronics में इसका बहुत application है, and ये बहुत rare है लेकिन. So any reserve of tantalum in itself is important. Jaise in this case, we have found it's a reserve in Satluj River. So we should know about tantalum also, few of its properties and the fact that we have found reserve in Satluj River. Hyperloop is another applications of maglev technology. This was for the this was in a paper published by Elon Musk. He talked about this new mode of transportation called Hyperloop. He imagined a rubber tube, some sort of tube, a vacuum tube. Why vacuum tube? Because there are two biggest problems in attaining higher speed. The first is friction and the second is air drag. Jitna zyada speed hoga utna zyada air drag hoga. So friction already we remove in case of magnetic levitation. जो bullet trains हैं, they do not actually run on the railway tracks. They run few centimeters above because of the magnetic repulsion, which I was talking earlier. This maglev technology, magnetic levitation technology. So you remove friction by allowing this maglev technology, and then inside this tube, you remove air from this tube, and then you remove the air drag part also. Goes without saying that inside the vehicle itself, we need air, we need proper atmospheric pressure, we need oxygen, all of those, that thing. Inside tube we do not want passengers to die there. And we also want that is a rubber tube hoga, that should be made of materials which can sustain the fear of vacuum collapse. Because remember, if there is no atmospheric pressure inside, outside atmospheric pressure has not gone anywhere. So outside force जो है बहुत ज़्यादा है. आपने वो न्यूज़ पढ़ा था जो टाइटैनिक सबमर्सिबल व्हीकल वाला जो न्यूज़ था. सो बहुत अंदर अब वाटर में चले जाओ, द वाटर प्रेशर बिकम्स सो हाई that this will lead to a implosion, basically a collapse here. So we do not want this vacuum collapse to occur, and for that we need to find materials which will not undergo vacuum collapse despite the fact that all the time they are going to have this very, very powerful atmospheric pressure from each and every direction. So that is why till now none of the hyperloops have actually become commercially active. Only and only they are in experimental stages, and it's been quite some time now. I remember Elon Musk publishing this paper like 10 years ago, 10 or I don't know exactly when. 2010 में कभी तो 2010-12 के आसपास पेपर पब्लिश करा था उन्होंने. And it's been more than 10 years and you do not have any commercial hyperloop anywhere in the world. This topic is in news. Tata Steel, another company startup in Hyperloop, TUTR Hyperloop, signed an MOU to jointly work on development of Hyperloop technology. So two things, maglev technology and creating a vacuum-like condition to remove the air drag, but goes without saying, we need to have materials which can sustain that atmospheric pressure and will not undergo through vacuum collapse. And simultaneously, you also need to maintain air pressure inside the vehicle itself with enough oxygen so that passengers, they do not suffer from anything. But you can theoretically, if we can achieve all of that, then we can attain speed of about 1200 1300 km per hour. In bullet trains in Japan or China, we attain speed of 500 600 km per hour. But in Hyperloop, that same speed can become 1000 or even 1100 1200 km per hour. That is the objective of Hyperloop technology. This we already discussed. एक हम मैग्नेटिक लेविटेशन भी हम यूज करते हैं, बट हम और भी मैग्नेटिक फंडामेंटली हम हर जगह मैग्नेटिक रिपल्शन यूज करते हैं. और मैग्नेटिक रिपल्शन के लिए हम सुपर कंडक्टिंग मैग्नेट्स यूज कर सकते हैं, बट देर आर अदर वेज ऑल्सो विच इट कैन बी डन. दोनों दोनों यूज कर रहे हैं हम. सिंपल मैग्नेटिक रिपल्शन, very powerful magnetic repulsion, and also superconducting magnetic repulsion. Both methods are being used. Here also I will start with space technology the same way we did in previous class. Then we'll discuss ICT, and then we will club biotechnology and health together in one. The very first topic, this will be a very important topic. So Aditya L1 had a lot of coverage. But XPOSat, even though it did not have a lot of coverage, it is a very important mission, a very unique mission. The reason why this is important is that it is a very unique mission, what it aims to do. And there are hardly any other mission, like there are 2 or 3 other missions which fall in the same category, or exclusively which fall in the same category. So for me, this is another very important topic from space technology we should know about. We should also go into factual details here. So ISRO launched XPOSat using PSLV. वो खुद में पता होना चाहिए हमको that we use this XPOSat. We should know few basic factual details. We use PSLV. We launched this satellite into an orbit of 650 kilometer, so low Earth orbit only, with very low inclination. It's almost an equatorial orbit, inclination of 3-4 degree. वो उतना हमको नहीं जानना. But low Earth orbit पक्के से clear होना चाहिए. And within low Earth orbit, it is at about 650 kilometers. So this much information we should know. Then the second thing, which is again very important, we should know here is that what it aims to do, what it aims to achieve. So the full form of this mission here is X-ray polarimeter satellite, XPOSat. And the both words are keywords here. So I have talked about this, that how light is information carrier, how light carries information with it. But light is not just visible light. I elaborated a lot about that in previous classes. Light is also gamma ray, light is also X-ray, light is ultraviolet light, infrared light, radio wave, and all light carries information. The object which it has been emitted from, the object it came in interaction with, it was refracted, scattered, reflected, whatever it did, but whatever process it underwent through, it carries information about that process. The same way which I discussed earlier, that how light being reflected from you allows me to look at all of you, or how light being emitted here allows me to look at this particular light source. So there are many X-ray sources in the sky. Universe does not speak to us only in visible light. Universe speaks to us in different frequencies of light. It in fact also speaks to us in gravitational wave, which we discussed in previous classes. So universe speaks to us in different frequencies of light, and that can also be X-ray. So the starting point about the objective of this mission, which should be very clear, that there are a lot of X-ray sources in the sky. In the universe, there are many X-ray sources. Some of the most prominent one which I have to talk about, supernova explosion, one of the most prominent source. Quasar, which I have talked about in previous classes, that super massive black hole feeding upon the nearby material. And black hole ke around jo accretion disk hoga, that is another great source of X-ray. Binary star systems, 2 stars revolving around each other, great source of X-ray. Collision of neutron stars with some other object, great source of X-ray. So there are many sources of X-ray in the sky. The first thing we should know here is that this particular space observatory located in LEO aims to know about those X-ray sources. That is the first thing. And the second thing, and only one more thing which you should know, that how does it aim to know that? It aims to know that by measuring something called polarization. So polarimeter is a device, and the same way we have a device called thermometer which measures temperature, or barometer which measures pressure. You have a device called polarimeter which measures polarization. But to do that, we first need to appreciate what is polarization. We have talked about this fact that light is electromagnetic wave. We have talked about this in previous classes, that it is vibration of electric and magnetic field. Both electric and magnetic field vibrate perpendicular to each other, and the wave in itself is perpendicular to both electric and magnetic field using right hand thumb rule. So my index finger electric field, middle finger magnetic field, thumb is the direction of the light itself. But this is a very simplistic picture. Turns out that this electric field vibration, so let's now focus only on the electric field. The electric field vibration is quite random in most of the cases. Just this light which is being emitted, if I look at the direction of the electric field of this light, I will find that it is in every direction, every possible direction. Iska koi fixed direction nahi hai. And this is what is shown here, that this yellow which you see, that is the direction of electric field, and all the time electric field is vibrating in all the direction. So whenever you have light where electric field has no fixed direction, it is vibrating in any random direction, this light is called unpolarized light. But there are so many ways this unpolarized light can be converted into what we call polarized light. And the moment I use the word polarized light, I'm now talking about it being vibrating into some fixed direction. That rather than having random directions of vibration, now the direction of vibration is quite fixed. It is vibrating in a very specific plane. That plane can be up and down, it can be circular also, but it has a very fixed direction or very fixed plane of vibration. There are so many different ways we can convert unpolarized light to polarized light. Simplest nature also does that. Whenever light gets reflected or refracted also, some of the light becomes polarized. Unpolarized light becomes polarized. But there are devices which can do that. Those devices are called पोलरवाइड्स और पोलराइजर्स. जैसे सन ग्लासेस अभी आपने पहने होंगे. सन ग्लासेस बहुत सारे आप जाओगे आप शोरूम में, तो आप उनसे पूछना कि आई नीड अ पोलराइज्ड सन ग्लास या पोलराइजर सन ग्लास, एंड दे विल शो यू that think of a very bright, they will show you a very bright light source, and just wear that sunglasses and it will remove the glare part of it. So what that polarizer is doing, it is converting that highly unpolarized light with random vibration with lot of glare, and lot of light is now being filtered out, and it will remove the glare part, and it will be soothing to your eyes. So in summer, for example, those polaroid glasses become quite popular in the market. So we can make devices which can filter that unpolarized, which can convert that unpolarized light into polarized light. But I should tell you that it already happens in nature also. Whenever light gets reflected, refracted, scattered, some of the light, if not all, even if it is unpolarized, जैसे जो sunlight है, that is unpolarized. But as sunlight gets reflected by a mirror, some of that light becomes polarized light. As it gets refracted by a glass, some of that light becomes polarized light. So polarimeter measures the polarization. कि जो X-ray है, that X-ray का जो polarization है, that vibration का जो पूरा angle है, what is the angle of that vibration? And turns out that different sources will have different polarization. Some sources, for example, a quasar can have a different polarization, or a supernova can have different polarization. And there are two, the last thing, there are two devices which aims to do that. One of the device as part of XPOSAT, POLIX. The first device is called POLIX. Polarimeter instrument in X-rays. And the second device is called XSPECT. दोनों का goal ये है that they will try to know about X-ray sources in the sky. So 3-4 things I will remember about this entire topic, but I will repeat, even though it is a very simple, straightforward topic, it's one of the very important topics for this year prelims examination. It is India's astronomical observatory, not the first one. The first one was called AstroSat. So we should know about that also. But AstroSat was a very general observatory that was launched in 2015, that it looked at all type of cosmic phenomena. XPOSAT, the second astronomical observatory which ISRO has launched, that looks precisely at X-ray sources in the sky. That is the first thing I will remember. We used PSLV for that. It is being launched. It has been launched into LEO of 650 kilometer. वो जो कुछ factual detail है वो भी पता होना चाहिए. Second thing. Third thing, the most important thing, that what are those X-ray sources it aims to know. So you can think of quasars or supernovas or accretion disks. All of those things are X-ray sources in the sky. And how does it aim to distinguish between that? By measuring polarization of that X-ray. What is polarization? It simply is a measure of the vibration of electric field of light. If it is random vibration in any direction, if vibration is happening, that is called unpolarized light. If that vibration is happening in a very specific direction, it is called polarized light. So by measuring the polarization, this particular satellite or this particular spacecraft with two of the scientific equipments called POLIX and XSPECT aims to distinguish among them. This much information I will remember for prelims or even for mains examination. I do expect that there can be a question on this topic. One of the probable topics, if I have to talk about, will be XPOSAT. POEM I already have mentioned that ISRO for quite some time now is doing this POEM experiment. जो PSLV का जो fourth stage है, I talked about that in previous classes. जो PSLV का जो fourth stage है, we are conducting very scientific experiments, experiments which do not require a lot of time. And so that fourth stage in itself has a lot of payloads, lot of scientific payloads. And before it could re-enter in the atmosphere, and yes, it will re-enter in the atmosphere, it will take about a month or two. But before it could do that, it will collect some scientific data and will send that data back to Earth. So those experiments are being called PSLV, Orbital Experimental Module, or in shortcut POEM. So it has been done 2 or 3 times till now. So this was, I think, POEM third. This was the third experiment in this entire series which ISRO is conducting. So that is also something we should know here. Let's take a break here. After that, we will resume the class. It does matter. That is not a question. So there is a, in fact, topic in the updated material in defense technology. Maybe I can discuss the topic here now that you have asked a question. The question is asking is that why do we use combination of solid and liquid fuel in rockets or in missiles for that matter? The benefit of solid fuel is that it is much more simpler to make. It is a very simple design. It's safer to store, transport, use. So overall your cost is less and you do not have to worry a lot about the safety factor. That is the benefit of solid fuel. The challenge in solid fuel here is that once it starts burning, then you cannot switch off that burning. You cannot control that burning. You cannot control the thrust. Only when all of the fuel will be exhausted. So it's not that it is impossible, but it is very, very difficult to control the burning. It is very difficult to control the thrust which you want to generate. So only when all of the fuel will be exhausted, that engine will automatically shut off and perhaps that part of the rocket will be separated. That is a challenge in solid fuel. Liquid fuels का जो challenge ये है, benefit तो पहले ये है that because it is liquid, so you have a container where you have fuel, you have oxidizer, and you can mix that fuel and oxidizer as you desire. So you can control the flow of the fuel to the engine, and because of that, you can also control the thrust. You can, if you want, if it is required, you can also shut down the flow. So that is also possible in case of liquid fuel based engine. So that is, it gives you a lot of flexibility. But the challenge in liquid fuel here is that they are much, much more difficult to store, transport, and maintain, which makes them expensive. They are not that safer in the sense, and because of that, you need to invest a lot into safety part of it. And the liquid fuel based engines jo honge, because of that, they will be much more sophisticated, technologically much more complex and expensive also. Jise ISRO ka jo liquid fuel based engine hai, that is called Vikas engine. So that is the fundamental difference. One more parameter which people often compare is that liquid fuels can give you higher impulse, like more speed. But that is not like a thumb rule. It also depends upon what type of solid or what type of liquid fuel you are talking about. But generally liquid fuels will have higher impulse compared to solid fuel. So there are certain benefits and shortcomings. So ऐसे समझ लो that whenever you only have to worry about uplifting or you do not have to worry about control, then you often can use solid fuel. But whenever you do need some control, then you will require liquid fuel. So that is why you'll often have this combination, mix and match of solid and liquid fuel. Okay. International Space Station, this was in news because despite so much of conflict between US and Russia, they have this very nice relationship where they cooperate at International Space Station. And one part of that cooperation is that one time Russia will send American astronauts and the next time America will send Russian astronauts. So space does allow you to cooperate globally, even with adversaries like US and Russia. And this program was extended. There was a fear that this program will be abandoned because of Russia-Ukraine war and US support to Ukraine. But this program has been extended. International Space Station is a collaboration among many agencies. You have Europe, America, Japan, Canada, Russia. It is the largest object, man-made object in the sky. It is in an orbit in thermosphere at the height of about 400, 450 kilometer, travels around Earth in about 90 minutes. Not the first station though, Russia had the very first station, but this is the largest object, and it goes without saying that not all of the components of this station can be placed in one go. So it was literally constructed, piece by piece, it was literally constructed into space, and it took quite some time for this entire structure to be completed. China also has its own space station now, Tiangong. and it has become active. So we should know about that also. Apart from International Space Station, you have Chinese space station called Tiangong. And even India has this plan to make Bharatiya Antariksh Station by 2035. पढ़ा होगा आपने न्यूज़ में, अभी कुछ दिन पहले न्यूज़ में था, प्राइम मिनिस्टर अनाउंस किया था. So this topic is an important topic, more important for mains though. Now this is important, Square Kilometer Array Observatory Project. This is International Space Station, like in all its full glory. SCOW. So this is an important topic. This was covered a lot into newspapers. And there is a reason. So this context in itself is important, that Union government has approved 1250 crore rupees for India's participation in Square Kilometer Array Observatory, SCOW. I just told you that how universe speaks to us in multiple languages containing light or gravitational waves or something else. And I told you that light does not have to be visible light, it can be many other type of light, including radio wave. So while X-ray is one of the highest frequency, radio wave has one of the lowest frequency. And there are sources in the sky which can emit radio wave also. The good thing about radio wave is that radio waves can cross through atmosphere also. They will not be often filtered out by Earth's atmosphere. While high frequencies light, such as UV light or visible light, if it is very dim, it will be filtered out by atmosphere. So we often have to go into the sky if you want to observe universe in visible light or infrared light or X-ray light, such as XPOSAT or Hubble telescope. But whenever you have a radio telescope, which by the SCOW is, then it's not an optical telescope, it's a radio telescope. It collects data about radio wave generated by distant cosmic sources. And it is not one telescope, it is a group of telescopes, many group of telescopes, radio telescopes, working in tandem, working like one giant telescope. And they are located, so one of the largest group of the telescope is located in Australia, and then another group of telescope is located in South Africa. So both Australia and South Africa are part of this. However, this entire project, which is an intergovernmental project, is headquartered in UK. So few things about SCOW. पहले तो ये context भी important है, that India has become member of this project. That in itself is important. It is an intergovernmental organization dedicated to radio astronomy. Second line, I will remember that. Aims to know about lot of things, including gravitational wave, but not limited to gravitational wave. Generally aims to know about radio wave sources, radio sources. And the last thing, that it is not last two things, it is not one telescope per se, but many telescopes, many radio telescopes working in tandem. And the largest group of radio telescopes are located in Australia and South Africa. But one telescope of India, this giant meter wave radio telescope, which has been playing or which has been collaborating with the SCOW project for quite some time now. So ये भी एक last चीज हमको ये भी पता होना चाहिए, that this giant meter wave radio telescope that is located in Pune, that is part of the or that has been collaborated with SCOW project for quite some time. But as of now, India has become fully fledged member of this entire radio astronomy intergovernmental project called SCOW project. So this is another important topic from space and astronomy, which we should know 2 or 3 things about. Okay. So what is your question? Time difference between? In case of SCOW, yeah. I haven't come across something like this. The question is asking is that to measure gravitational wave, it aims to know the time difference between things. I haven't come across this. I will not be able to comment upon it because I haven't come across that how it aims to measure gravitational wave, frankly. इसका purpose जो radio astronomy में, that it aims to know about radio sources, maybe what you were saying. So we can understand the time difference though, that if it is using time difference to detect gravitational wave, the question is asking is that one of the objective here is to detect gravitational wave, and it is going to measure the time difference. But that we can understand. We have talked about this. That one of the thing gravitational wave does is that it compresses and stretches space itself. And जो telescopes का जो distance है, that is fixed on Earth. But if the space between them in itself is changing, then with the help of sensors which can accurately measure how much time it takes for light to travel, maybe we'll be able to determine that if gravitational wave has passed through or not. So that is how we can perhaps know about or we can detect gravitational wave. Although how sensitive this is and how reliable this data will be, I'm not very sure about it, because there are dedicated gravitational wave observatories which are much more reliable source, because gravitational wave के जो changes हैं वो बहुत minute हैं. They make very small change which occur on the scale of nanometer. जो space के बीच का जो change है, that occurs on the scale of very small scale. And to precisely determine that change, how much SCOW is equipped, I frankly do not know. But I can understand in principle how, if it is doing that, what will be the principle of the working here. Reusable launch vehicles. This is a very popular concept in modern times. Many space agencies already have this capability. NASA has this capability. अमेरिका का जो एक बहुत फेमस प्राइवेट कंपनी है SpaceX, एलन मस्क जिसके CEO हैं, they have this capability. They have this rocket called Falcon, and Falcon has this capability of reusability. Reusability is very important from two perspectives. First, it reduces your cost, goes without saying, that if not all of the rocket, at least the first stage of the rocket, which often will be the largest, if we can recover it unharmed, unaffected, that it has ejected rest of the rocket, but then we recovered it unharmed, and then we can reuse it after refueling or some minor repair here and there, we can reuse it for the next launch. So it reduces your cost, because as of now all of the rocket is a new rocket. Of course the design, the engineering, everything is same, but every rocket is a new rocket, and space launches, because of that, they are very expensive. तो एक जो clear benefit है reusability का, that it aims to reduce cost. The second benefit of reusability here is that rocket uses lot of parts which may not be in huge supply on Earth. Lot of rare minerals which rockets use, and they may not be in huge amount on Earth. So it makes more sense to recover and reuse them. So that is another reason why we should, or why any agency should invest in reusable rocket. ISRO is working on a rocket which as of now they call it NGLV, Next Generation Launch Vehicle. And I don't think UPSC will ask a question on this, because you do not have a lot of information about this rocket except that ISRO is working on it. And ISRO has a target of achieving a capacity of 10,000 kg in GTO, Geo Transfer Orbit, and 20,000 kg in LEO. That will be the most powerful rocket designed by ISRO. अभी जो सबसे most powerful rocket है वो LVM-3 है, 4,000 kg in GTO, 8,000 kg in LEO, and we want to increase this by more than 2 times. So when will this happen? We do not know, but ISRO chairman also announced that one of that variant of this rocket will be reusable. अब reusable जो rocket variant होगा उसका capacity थोड़ा कम होगा, because it needs that fuel for the return journey. So ISRO for quite some time now, they are investing into demonstration of reusability, that in a limited controlled manner can we reuse a particular vehicle. And the last demonstration which they did was hardly like 2-3 months ago. They called this reusable landing vehicle Pushpak, and this was actually launched. First it was dropped with the help at very high altitude, it was dropped from a plane, and then this vehicle was stopped with the help of parachute. So this was the vehicle. This is the Pushpak vehicle, which was stopped with the help of parachute. So you can find like the demonstration video is available on YouTube, hardly like 1.5 minute video, that it was dropped from very high altitude, but then it made a path on an airline, and with the help of parachutes we were able to reduce its speed and we were able to recover it. What SpaceX does is actually much more interesting. SpaceX reorients the direction and then using the rocket fuel itself generates an upward thrust and lands it on a ground. So maybe ISRO will also do that, or maybe ISRO will do this, we do not know, but ISRO is working for reusable rocket. That part we should know. GSAT-20, new communication satellite. for this ISRO used Falcon, the rocket which I was just talking about, जो SpaceX का rocket जो है Falcon, they used Falcon for it, and the reason is that the mass of this satellite was 4700 kg, and it was a communication satellite. So communication satellites are launched in geosynchronous orbit, and the most powerful rocket we have is LVM-3, but that has capacity of only 4000 kg. So because its mass was more than 4000 kg, we had to use SpaceX Falcon 9 rocket. New Space India Limited, which is a PSU 100% owned by Government of India, works under Department of Space. It has been playing a very important role in making of rockets, but also launching of satellites now. So this satellite was launched by New Space India Limited. A weather forecasting satellite belonging to Ministry of Earth Sciences was placed successfully by ISRO. The name of this satellite is INSAT 3DS. इससे ज़्यादा और भी कुछ जाने की कोई ज़रूरत नहीं है. So INSAT 3DS is a weather forecasting satellite. Weather forecasting satellite we can launch in LEO, in polar orbit, but also in geosynchronous or geostationary orbit. बाकी सारे टॉपिक्स स्मॉल टॉपिक्स हैं. I will quickly run through them. कार्टोसैट 2. सो कार्टोसैट सीरीज ऑफ सैटेलाइट जो था, कार्टो का मतलब कार्टोग्राफी है, मैप मेकिंग सैटेलाइट. सो सैटेलाइट्स जिनका डेटा यूज करके वी डेवलप वेरियस टाइप्स ऑफ मैप्स ऑफ इंडिया सरफेस, different type of maps. Many of the maps, many of the maps which you have in your atlas, there is a very good chance that they may have been developed using remote sensing data of Cartosat series of satellite. So one of the thing which agencies are supposed to do, that whenever a satellite has become defunct, then ideally you should place them, if it is in high orbit, then you try to place them in an even higher orbit so that they do not cause any trouble to other satellites in the space. And if it is in low orbit, then you try to give them a boost so that they can re-enter in the atmosphere and they can burn up, and again they will not cause any problem to other satellite. Because if a satellite which is not functional anymore and still revolving around Earth is a debris essentially, and space debris is a serious issue. So there is a code of conduct for space agencies. This code of conduct comes from another global organization called IADC, Interagency Debris Coordination Committee. That is not mentioned here, but we should know about that body also. There is a body called UNIADC, United Nations Interagency Debris Coordination Committee. इस बॉडी का गोल ये है that whatever information we gather about debris, let's share that information with each other. And many agencies are part of this body, including ISRO. So ISRO is member of this body UNIADC. And one of their code of conduct here is that whenever you have satellites which are defunct, then ideally you should remove this. ऐसा नहीं कि कोई legally binding mechanism है. Like there is no law here, or there is no obligatory mechanism. It is just a code of conduct which agencies, responsible agencies, have to adopt, that whenever satellites have become defunct, either if they are in low orbit, place them towards atmosphere so that they can burn up, or if they are in high orbit, place them further higher. Those orbits are called graveyard orbit. जैसे मान लो there is a satellite in geostationary orbit, 36,000 kilometer. Then you place them at a height of 45,000 kilometer, let's say, or 50,000 kilometer, which are called graveyard orbits. Literally graveyard hai. They are not going to bother any satellite, useful satellites into geosynchronous or geostationary orbit. And this is not the first time ISRO has done. ISRO has done it number of times. Just one line, Proba 3 mission. This will be European Space Agency mission. Will be launched by ISRO though. And Proba 3 will be a unique mission in a way that it will have two objects, and these two objects will fly precisely. So they will fly in a very precision information together. And that mission is called Proba 3 mission. So European Space Agency ka plan ye hai that can we have a synchronized revolution using two or more than two objects. So to do that, they will be using ISRO's facility, maybe this year only, next few months. This mission will be Proba 3. मार्स पे बहुत सारे रोवर्स भेज रखे हैं नासा ने. जो अभी सबसे रिसेंट जो उनका रोवर है वो परसिवियरेंस रोवर है, and perseverance rover contained that small helicopter called Ingenuity helicopter, and it was able to fly on the surface of Mars. This was, it's not a recent news, it's a 2 year old news, 2 साल पुराना news है, but we should nonetheless, we should know about perseverance rover and Ingenuity helicopter. And this was, I remember this was covered a lot, because think about how much human beings have developed in last 100 years, like Wright brothers having first flight in early 20th century, and just 100 years later, about 100 years later, you have a flight on the surface of Mars, even though unmanned flight, but that in itself is quite amazing, that you can fly an object on the surface of Mars and you can have a much bigger perspective about what it looks like. These two objects, Voyager 1 and Voyager 2, are the two most distant objects from Earth, launched by NASA about 4 decades ago. And recently, Voyager 1 communication breakdown had occurred, but as of now, it has been restored. So that in itself is it can be further rectified, that this has been restored. So as of now, Voyager 1 se information jo hai, NASA is able to collect that information. And as of now, both of these missions are not even part of solar system. They are part of what we call interstellar medium. So they have crossed solar system, and they are so far away that it takes about 18 hours for light signal, radio signal, to travel to Earth here. So whenever they emit a signal, 18 hours later, that signal is received on Earth. So they're very far away. They are not part of solar system as we speak. Lunar environment को gather करने के लिए there is a private satellite launched by SpaceX, not important. James Webb Space Telescope has this program called Uncover program, जिसका purpose ये है to know about epoch of reionization. This is a very precise concept in cosmology. I do not expect such questions to be asked by UPSC. So I will just define in one line what does this word epoch of reionization mean. In the previous classes, I have talked about cosmic microwave background radiation. Discuss किया था हमने CMBR. So even when universe became transparent, cosmic microwave background radiation, there was not enough light in the universe, because universe was only made of neutral hydrogen atoms which were neutral. So you did not have enough light. You had a lot of gaseous giants made of hydrogen, but you did not have stars. But because of the gravitational force, as those gaseous clouds collapsed and started forming stars, when nuclear fusion started happening, that nuclear fusion produced so much of energy that it ionized nearby things. And as things became ionized, they started producing more and more light. So this particular event after Big Bang, this particular event is called epoch of reionization. So this happened after cosmic microwave background radiation, after universe became transparent. This is one of the most famous theory in cosmology, that some of the major events how universe went through. So you have Big Bang, you have then this universe becoming transparent, which we call cosmic microwave background radiation. Then you have this epoch of reionization, where universe started producing much more light. And this must have occurred because of the formation of first group of stars and galaxies, because these stars and galaxies produced so much of energy that they ionized nearby hydrogen atoms, and they started producing more and more light. So hence the word epoch of reionization here. And the purpose of Uncover program, so Webb telescope का जो भी data हम gather कर रहे हैं, the goal of Uncover program is to know more about this epoch of reionization. High altitude pseudo satellites. It is essentially a type of drone which can fly at very high altitude and can maintain orientation or maintain a line of sight of a particular location. So drones flying at low altitude, flying with very high speed, they will only be able to observe a particular part of Earth for a very small duration. But drones flying at, let's say, 40-50 kilometer, and now they can maintain line of sight of a particular location for much longer duration, will be very useful for surveillance, particularly in defense area. Hence the word high altitude pseudo satellites. But we are not talking about satellites, we are essentially talking about drones here. So National Aerospace Lab, they have completed test of a solar powered pseudo satellite. तो इसके power source के लिए हमको again कोई fuel वगैरह carry करने की जरूरत नहीं है. It can be powered by sunlight, which is a good thing because it can operate for hours without the fear of fuel requirement. ISRO has developed a second generation DAT. DAT is basically a device which will allow you to communicate, as well as it will allow you to, it's like a GPS receiver, but it also allows you to communicate. So if you are into deep sea, few kilometers away from the, let's say, coastal shelf, where you have no mobile tower, no internet, and suddenly there is a disaster, some cyclone or powerful wind surge is developing, and you have to alert authorities that somebody will be able to come and rescue you, you can use this device. This device will use satellites to determine your location where you are, and will also allow you to communicate with authorities. So ISRO has developed this. It can have applications in many areas, but particularly in fishing. Now this is an important news. This is an interesting news. Kulasekara Pattinam Spaceport in Thuttukudi district of Tamil Nadu. So we know about Sriharikota. Sriharikota is our launching station for rockets. But the next spaceport, which ISRO already has, everything has been approved. And particularly जो small satellite launch vehicle है, जो हमारा सबसे small rocket है. I have talked about SSLV. SSLV is this very small rocket, 3 stages, solid, 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 500 kg, 500 kilometer, and that will be launched using this spaceport. Let me in fact show you its location. Now this location is important. So one of the reasons this location is important here is that you do not have, abhi jo Sriharikota hai, it avoids Sri Lankan airspace. We do not want to fly above jo rocket hai. We do not want this to fly above Sri Lanka, because rocket produces a lot of debris which fall down on the ground, and we do not want those debris to fall in Sri Lankan mainland. So it first moves south, then moves east. So it has to avoid Sri Lankan land mass. But यहाँ पे वो ज़रूरत नहीं है. यहाँ पे we do not have to fear that. We can directly launch our rockets in southern direction if you have to launch something into polar orbit. So that is the benefit. And second benefit is that compared to Sriharikota, it is closer to equator. And the more you are close to equator, you have more rotational speed तो हर जगह same है, but जो आपका linear speed है, equator moves much more faster compared to higher latitudes. तो अब जितना ज़्यादा equator के पास हो, you have more and more momentum. So whenever you launch a rocket near equator, then rocket is already had some momentum of Earth. And if you then match Earth's momentum, then you get some sort of help here. So that is another benefit of this particular spaceport. But more than that, I think the Sri Lankan airspace ko avoid karne wala, that is another benefit. So this is a important news. The location part and the significance of the location, ये दो चीज हम याद रख सकते हैं. And of course we can remember that Sriharikota is another rocket launching station. Not the first though. The first was, one was, which was our first rocket launching station? Thumba, near Thiruvananthapuram, right? Shiv Shakti is that point where Chandrayaan 3 landed. And you have this body called International Astronomical Union, which does a lot of things, including whenever we on moon or on, let's say, other planets, if we have to name a particular point, then that approval is done by International Astronomical Union, and they have approved this point, Shiv Shakti point. So any question in space technology, if you have, you can ask questions. Sorry?
Polar code last year.
Polar code, okay.
Around for shipping and सर
Okay.
ऐसा कोई कोड मतलब उसमें भी है क्या ऑर्बिट जैसे
पोलर कोड तो शिपिंग इंडस्ट्री को लेके
आई एम आस्किंग कि कोई सिमिलर कोड उसमें भी है क्या जियो जैसे लोअर अर्थ ऑर्बिट या फिर
लो अर्थ ऑर्बिट में तो कोई कोड नहीं है. But if your question is that do we have some sort of regulation in launching of satellite? So in communication satellite there are regulations. जैसे particularly जो geosynchronous and geostationary orbits हैं, they are very crowded and they are often used for telecommunication. So you have this regulation of International Telecommunication Union, which is an agency of United Nations, and that regulates launch of satellites into geosynchronous and geostationary, and particularly communication satellite. But you do not have a legally binding arrangement or some sort of code like polar code which you're talking. You do not have something like that here. Any other question if you have? यहाँ पे जो सबसे important topic, two topics if I have to talk about from space technology in the updated material, one will be ExpoSat, the second will be SCOW. Let's quickly complete IT and computers. We do not have new topics, lot of new topics here. We have discussed many topics. जैसे we have talked about AI in much more detail in previous classes. यहाँ पे बस दो चीज I will highlight, 2-3 things I will highlight. The first is that Union Cabinet has approved more than 10,000 crore rupees for India AI mission. Second thing I want to highlight here is this word graphic processing unit. So the processing units we use in our day-to-day life computer is called CPU, central processing unit. We call this brain of computer, right? The reason because it does the computation part. Computer does computation and computation is done by CPU. So what is a GPU, graphic processing unit? So GPU is a very specialized type of hardware which is very good at few type of calculations, particularly if you have parallel calculations. So जो सेंट्रल प्रोसेसिंग यूनिट है उनके कुछ कुछ बेनिफिट्स हैं. तो सबसे पहला बेनिफिट ये है दैट दे आर गुड एट मेनी थिंग्स. जो सीपीयूज हैं दे आर गुड एट मल्टीपल थिंग्स. जो सीपीयू का पूरा जो डिज़ाइन है, जो वायरिंग है, जो स्ट्रक्चर है, that allows it to perform various type of calculations. That is one of the most important benefit. It is cheaper to manufacture them compared to GPU. They are simpler in terms of their design, but they do one thing at one point of time, which is called serial processing. They do not do many things at one point of time, and that is where GPU differs from. So graphic processing unit is a specialized hardware. It will not do many things like a CPU can do, but whatever it can do, whatever few things it can do, it will do that billion times faster than central processing unit, because it does many parallel calculations. It can divide one problem into many smaller parts, and it can do many parallel calculations. All of those problems can be simultaneously solved. So it escalates the computation time jo period hai. And this is essential to supercomputing facilities, but this is also essential to AI, because remember modern AI tools, when we think of GPT, ChatGPT 3 or 3.5 or 4 or 5, whatever OpenAI is developing, or when we think of Gemini developed by Google, all of them essentially are training their generative AI tools on huge amount of data set. So they do require dedicated hardware. जो AI को train करने के लिए जो आपका पूरा hardware है, they do require dedicated hardware which can do computation, which can do calculation on huge amount of data set together. Hence the word graphic processing unit. So this topic जो line दे रखा है, that deploying over 10,000 graphic processing units for advanced AI computing infrastructure. So as of now, for AI systems, the type of chips which are used are very different. NVIDIA, but NVIDIA is one of the big tech company, and they specifically are designing GPUs for OpenAI. जो OpenAI का जो GPT program है, उसको better करने के लिए. So this is what India also aims to do, that let's try to develop graphic processing units in India. So CPU, GPU comparison, I will compare this on only two parameters. CPU, good at many things, but less speed, and does one thing at one point of time in a series of distinct operations. GPU, good at few things, but really, really good at few things, billion times faster than a typical CPU at those few things, does many things together, which is called parallel calculation. That GPU as a hardware is fundamental to technologies like supercomputer, but also to artificial intelligence. Baki LLMs, all of these are various type of initiatives taken by Government of India, like Bhasini, Airawat supercomputer, all of that. Bharat GPT group led by IIT Bombay launched Hanuman, ChatGPT like service. We have talked about AI regulation in previous classes. One of that, which we discussed in previous classes also, but this is mentioned, that European Parliament has now passed an act, the first regional group to pass an act like this, Artificial Intelligence Act, and where they particularly have identified the risk and they have divided all of that risk into 4 category, and different risk पे जो intervention होगा, जो punishment होगा, penalty होगा, वो बढ़ते चले जाएगा. Next topic is given as fourth industrial revolution. I'm not very sure how you can have specific questions on fourth industrial revolution in prelims examination. I do expect this theme to be asked by in mains or even in essay, but I am not very sure how this will be asked in prelims examination, because fourth industrial revolution is not one term. Few things we should know. जैसे nomenclature का meaning क्या है, I'm only going to explain that part. The first industrial revolution happened in England in mid of 18th century, somewhere around 1750. Steam power, coal-based steam power engines, textile industry, fundamental indicator. Second industrial revolution, that happened in rest of the Western Europe, including countries like Germany, Spain, Italy, all of Portugal, all of these countries, but also including Japan, Canada, and America. That happened from 1850 to 1914, जो पूरा World War I के पहले का टाइम है. World War I, World War II उसको खत्म करो. After World War II, 1950s to 1960s, 70s, 80s, that based all of the revolution which occurred because of development in computational system, IT, information technology, we call third industrial revolution. Now, fourth industrial revolution is not one term. Almost all of the technologies which we have talked about, particularly from ICT and from material sciences, all of that together will be called example of fourth industrial revolution. So all of the developments in computing, such as supercomputing, quantum computing, all of the developments in manufacturing, such as 3D printing, all of the developments in communication technology, quantum communication, cyber cryptography जो भी हम use करते हैं. So all of that collectively together is called fourth industrial revolution, which is happening right now. As we speak, it is happening right now. And this is what is mentioned here. So it is not one thing, and Government of India has this focus on fourth industrial revolution. We have many institutions, many initiatives to promote fourth industrial revolution. I'm not very sure that how the question in prelims will be asked from this topic. This we have talked about in previous classes. So quantum communication, particularly I talked about quantum key distribution. I mentioned that the public key distribution, it aims to secure your data using mathematical problems which are very difficult to solve. But very powerful quantum computers can solve those problems, and that is a threat to cyber security. And that is where the concept of quantum key distribution emerges, where we use principles of quantum mechanics such as quantum entanglement or superposition to now share a key, but that key is not decipherable, and that key is tamper proof. If somebody does tamper it, then the sender and receiver immediately know that it has been tampered with, and this key will be abandoned. So we talked about all of that in previous classes. So a new addition here is that Center for Development of Telematics, they have developed quantum key distribution. This is a new news which we should know here. Satellite-based toll collection system. Toll payment is a huge headache. It was a bigger headache before FASTag, that you wait for so long period. लंबा लाइन है टोल के पास. FASTag के बाद चीजें थोड़ी सी improve हो गई हैं. That you have this FASTag. In the QR code, you have the information about a wallet which is connected to your bank account. When you go to toll, this particular FASTag reader can transmit its information to this particular reader, that जो FASTag reader है, that uses a technology called radio frequency identification technology, that it can read that tag even for even from a distance of, let's say, 50, even 100 centimeter away, and then it can establish a connection where automatically the amount will be deducted. So all of that we already know, already has occurred. But things have improved, but still it is a headache. The new method, and by the way, this was announced by ministry few years ago, but now concrete works have started happening in this direction. GPS-based toll collection system. This will include two things. First, an online board unit. That online board unit essentially is a GPS receiver, that your location can be calculated, a GNSS enabled device, a GPS enabled device, And second is that automatic number plate reader cameras, that on highways जहाँ पे अभी toll booths हैं वहाँ पे cameras होंगे. These cameras will capture the image of your number plate, and you using AI systems, using computer vision or using some other technology, that number plate will be linked to a particular bank account, and further this will be confirmed from the GPS data itself, and automatically money will be deducted. So no human intervention, no those toll booths, no those, not those long lines. यहाँ पे एक चीज बहुत क्लियर होना चाहिए, that government is actually not tracking your movement of vehicle. That will be a gross violation of privacy. So it already works in many countries, and this works in a way that whenever you cross a pole, in other countries that is how it happens. Whenever you cross a pole, that automatic number plate reader activates first, and GPS data is then used to confirm that you actually have crossed a particular place. That GPS receiver is used to confirm it. It's not that government is tracking your movement, that where you are and where are you going and what is the route you are taking. That will be a gross violation of privacy. So, but nonetheless, whenever, whatever you, even if you cross, that GPS data will definitely be stored on the government server. That is there. But it is not a continuous tracking of your movement. And this is how this toll collection will work. इसका benefit, सबसे बड़ा benefit यही है कि पूरा congestion जो है वो हमारा ठीक हो जाएगा, खत्म हो जाएगा. Older devices को will have to equip them with GNSS receivers. But as of now, government is not trying to replace the FASTag system. It is trying to add this feature, and gradually perhaps FASTag will be replaced, but that will take some time. A similar technology of RFID is a technology called near field communication technology. Near field communication technology is what we use when you use your debit card or credit card on a POS machine. You do not have to insert the machine, add your PIN. You just have to bring your card very close to the machine, and you automatically, money gets deducted. So for this, for a temporary period, whenever you need आपका जो debit card or credit card, it needs data. So whenever you go very close to the POS machine, for example, for a very temporary period, it creates a communication channel. And within this communication channel, with the help of radio waves, it allows data to be received by that POS machine in an encrypted form. So ऐसा नहीं है कि this data is random data, open source data. This data will be shared in encrypted form and money will be deducted. And the moment you remove your card, like few centimeters away, this communication channel is broken. So this is a temporary communication channel which is only and only created if you are very close to the device which can read an NFC tag. And for that, close का मतलब यहाँ पे less than 10 centimeter है. So only when you are in less than 10 centimeter, NFC system is going to work. That a temporary communication channel with the help of radio wave data transfer in encrypted form has multiple set of application. The most important is payment application. So this topic is in news because जो नेशनल पेमेंट कॉर्पोरेशन इंडिया का यूपीआई टैप है, अभी तक हम क्या करते हैं, क्यूआर कोड स्कैन करते हैं. सो रादर देन क्यूआर कोड स्कैनिंग क्यूआर कोड, वी कैन नाउ यूज दिस एनएफसी टेक्नोलॉजी द सेम वे वी यूज फॉर डेबिट कार्ड एंड क्रेडिट कार्ड. जो यूपीआई है, वी कैन डू दैट विद द हेल्प ऑफ एनएफसी. सो दिस इज व्हाट गवर्नमेंट ऑफ इंडिया इज प्लानिंग and is working upon. Submarine cable system. All of the world is connected through this optical fiber cables, giant optical fiber cables, which will look something like this inside ocean. Often they are installed in collaboration with many companies, and companies not from one part of the world but many part of the world. They work as a consortium, and then they invest into this giant infrastructure which allows global interconnectivity of devices with internet as an infrastructure. So this is the first thing we should know, that modern internet works because all across the world, inside oceans, you have optical fiber cables, very strong, deep optical fiber cables, which can handle huge amount of data every second of time. And then all of the devices which are part of the internet, they follow same protocol, same rules and regulations. And that is how each and every device can find each other. And whatever data is stored at some web server, I can access that on my laptop or on my mobile phone. But none of this would have worked without such type of infrastructure. So why this topic is in news? That right now, ये जो पूरा area है, this area has become prone to a lot of conflict. So conflict because of Israel-Palestine, but जो Houthi rebels हैं in Yemen, they have become very active. Piracy activity has increased a lot in Indian Ocean. So there was a news here, the damage to 3 submarine cables, and particularly जो Europe India gateway cable है, Tata Global Network, that has been damaged, and that can actually have adverse impact on the internet data traffic India goes through. So India, for example, few things here. There are hundreds, thousands of connections, and India के mainland connections खुद के अपने जो भी हो, but India is connected at 17 such SMC submarine cable stations, landing at 14 landing stations and only in 5 cities. So India is connected with rest of the world with its submarine cables at 5 cities. All 5 of them are located on eastern coast and western coast. But within India, we have our own system also. For example, you have this Chennai Andaman Nicobar Island cable system or Kochi Lakshadweep Island cable system. The essential point here is that without this cable system, this data traffic which internet flow manages would not have been possible, and that was damaged because of the conflict which is happening in West Asia region. Optical fiber cables, they themselves use the concept of total internal reflection. That optical fiber cables are very thin, but if you magnify them, you are going to find 2 layers. So I'm not interested in that outer plastic coating. I'm talking about the 2 internal layers. That yellow which you see here, that is called core, and just above core there is a cylindrical another layer which is called cladding, and core will have higher refractive index compared to cladding, in a way that when light pulse enter inside core, it undergoes total internal reflection, and this light pulse can now travel thousands of kilometers without losing its signal strength, without any type of spread. So that is why optical fiber cables, they allow you to handle huge amount of data without loss of data quality. नॉर्मल डिस्प्ले टेक्नोलॉजी जो हम लैपटॉप्स या आईपैड्स या टैबलेट्स जो भी हम यूज़ करते हैं, they often have some light source, different depending upon what type of display you have. The light source can be different. Just if you have LCD display, then if you have LCD display, if you have LCD TV, for example, open your TV. Behind your TV, you have this backlight, white light. There are many filter substrates. As this light passes through those filters, it produces all these different colors. If you have sophisticated LED TV like OLED TV, then you have these light emitting diodes, very small diodes. If you can open the front panel of your TV, or for that matter, आपका जो mobile phone का जो display है, that also uses the same thing, better sophisticated version of it, but it has its own light which is emitted. It does not rely upon a backlight, but it does have a light emitting diode of red, blue, green color, and just by changing the intensity of that red, blue, green, we can produce all types of color. So display technology has come a long way. Things have become really good. We have high definition, ultra high definition, all of those things which we know and which we use in our day-to-day life. One of the problem of this display technology is that it is straining to our eyes. Looking at laptop for very long, at a screen for very long, it affects your eyes also, but it definitely causes some sort of headache, and you cannot concentrate. Just say I ask you to read a PDF, and then I give you a book, and you can read that book for longer time, but reading that PDF on a laptop, that will not be very good. I think for most of the people will agree with me that this continuous light, bright light is not very good, and you will simply say that I will read it later after half an hour or so. But a book you can read for 4-5 hours. Electronic ink is very similar to a book. So in a book, you have this white page, you have this ink, you printed this ink, it created all of those words, and you can read this in the presence of room light. It's not emitting its own light, so it is not straining your eyes. It is using the reflected light, and overall you can read it for much longer duration. So an electronic ink display, इसका जो सबसे बढ़िया example है, वो है Kindle डिवाइस. किसी के पास Amazon Kindle है? So if you have Amazon Kindle, for example, Amazon का खुद का अपना एक डिवाइस है which is called Kindle. Kindle is a book reader. But Kindle पे जब आप बुक पढ़ने जाओगे, you'll not find it at all straining. It's like normal book. The only thing is that it is an electronic device which you charge. It has a battery, you charge it, but the display is very soothing to eyes the same way you read a book. You do not find lot of difference except that what it looks like or the fact that it is electronic device. So that Kindle is the best example of electronic ink display. So electronic ink display का जो structure है, that you have two type of substances here. We can call them, let's say, for example, pigments here. These are pigments of white color and black color, but these are charged pigments. You have, just for example, in this case, I have this white pigment of, let's say, positive charge and black pigment of, let's say, negative charge. You have electrodes and then you have layers. And by the way, this is a zoomed version of the picture. The actual size of one pigment will be thinner than a hair. आपका जो hair का thickness है उससे भी ये thin होगा, जो एक pigment है यहाँ पे. And in such type of arrangement, so now how this display will work, whenever I want a black display on the white substrate, I just have to, so right now this is negative charged and the layer below it is positive charged, it is here. But the moment I want a display, I will change the charge here. I will change, this is negative charge, but I will change the lower layer to it to negative charge. This will lead to repulsion and it will go up, and that will create a particular type of display. So it is not using any light per se, it is not emitting light per se, it is using the concept of electromagnetic attraction and repulsion to create a display on the surface of particular device. And because of that, since it is not emitting its own light, it has very long battery life. So while an iPad will be discharged in few hours, a Kindle device can work for 7-10 days. आपको 7-10 दिन चार्ज करने की कोई ज़रूरत नहीं है, और आराम से काम करेगा. खुद का कोई लाइट एमिट कर ही नहीं रहा है. जो उसका डिस्प्ले है, that display is not because of light, that is because of this electromagnetic attraction and repulsion here. That is the benefit of e-ink display. Second benefit here is that it is not straining to your eyes. You can read it for much longer duration. Challenge here is, that is also very simple. Two challenges I will highlight. The first challenge here is that आपका color combination बहुत limited है यहाँ पे. That सबसे simple color combination जो है white और black का है, that you use that, and that does not allow you to make colorful display. Things have improved in recent times. In recent times, few companies are working on some other colored pigments, but even then, the type of color you can have in, let's say, your mobile phone AMOLED display is many times much more than a typical electronic ink display. So now electronic inks are capable of displaying colorful display also. However, they still have lot of limitation. That is the first challenge. And the second challenge is कि इनका जो refresh rate है, मतलब when refresh rate को आप intuitively ऐसे समझ लो that when I change from one page to another page, and how easily that is happening. So in case of mobile phone, it is happening very smoothly. Whenever you change things, things are happening very smoothly. In case of electronic ink display, that refresh rate will be less, and it is not going to change very smoothly. So there are two limitations also of electronic ink display, but two fundamental benefits जिसके कारण वो actually बहुत popular है, that it is not straining to eyes, and it has a much larger battery life simply because of the fact that it is not using some sort of its own backlight, or it is not emitting its own light. The display is because of electromagnetic attraction and repulsion. Some students of MIT developed this technology, and the company which has patent of this technology, that company is literally called Electronic Ink Limited. So it's a relatively new technology, and Electronic Ink Limited has the patent of this particular technology. डिजिटल ट्विन का कॉन्सेप्ट हमको पता होना चाहिए. Digital twin simply means that I have a physical object. I create a perfect copy of this object, a digital perfect copy of this. What does that mean? Just in this particular case, I have this aeroplane. Aeroplane had some dimension, some mass, and I created a perfect digital copy. Now I can simulate this particular plane. For example, I can understand that how this plane will behave if, let's say, for example, wind condition worsens, if weather worsens, how it will behave if many passengers are just sitting in the back, how it will behave when many passengers sitting only in the front. So I can simulate this without going for the actual experiment. I can do all of that on its digital twin. So digital twin has to come as close to a virtual representation of a physical object, but it should be as close to as the physical object. As close to as का मतलब यहाँ पे ये है that whatever is subjected or whatever this physical object feels in real world, can we simulate the same in a visual world? So that simulation will allows us for better design and better planning. So digital twin simply means we are talking about a virtual representation of a physical object, and that virtual representation allows us better simulation on a computer, and now we can use it in so many different areas. Even for human beings, for example, think of your organ systems, that I have created a digital twin of our organ systems, and we are trying to understand that how various organ systems are dependent upon or interconnected to each other. So I can have a digital twin of human body internal organs, or I can have digital twin of a very large bridge connecting two parts of the river, the opposite sides of the river, connecting perhaps two cities, or I can have a digital twin of an aeroplane which I showed. So it allows us to do better simulation and how a system, a complex system will behave when parameters, when variables are changed. So this topic is in news because Department of Telecommunication has unveiled this Sangam Digital Twin Initiative. प्रूफ ऑफ कॉन्सेप्ट का मतलब ये होता है कि आपके पास एक डिजाइन है आपके मन में और आपने उसको इंप्लीमेंट कर लिया. दैट इज द मीनिंग ऑफ द वर्ड प्रूफ ऑफ कॉन्सेप्ट. डोंट वरी अबाउट this word proof of concept. It's not as technical as proof of work or proof of stake, which we have talked in previous classes. Nothing to do with blockchain technology. So I don't know why they have like bold में क्यों करके रखा हुआ है. So proof of concept simply means that you have something which you actually have implemented rather than only as an idea in your mind. That's it. I don't think more than this is required in this particular topic. Just understanding of digital twin is more than important in this particular topic. Any question if you have in any of the topics we have discussed? We have one more class next week. We'll discuss rest of the topics in next week. बहुत सारे लोग आपको नींद आ रही है. So आज का क्लास of too much information in one class. अगले क्लास में करेंगे हम. हाँ बिल्कुल, go ahead.
Which gases are released during extraction of diamonds?
I'm not very, so the question is asking is that which gases are released during extraction of diamond. That is a very specific question, factual question. But if I have to guess few things, I can guess few things at least. जैसे कार्बन के जो gases हैं, कार्बन मोनोऑक्साइड और कार्बन डाइऑक्साइड, they will be released. Sulfur dioxide definitely will be released. Nitrogen is not a lot in Earth's crust. They say you do have lot of carbon dioxide or sulfur dioxide, or even radon. Things like radon can also be released. I'm not very sure about nitrogen, but if there is an option that some gases of nitrogen will be released, I will not consider that to be wrong. Although it's a very factual question and a very specific question. Why did you ask this question? किसी टेस्ट सीरीज में आया था? हाँ, तो ऐसे टेस्ट सीरीज के क्वेश्चंस को उतना ज़्यादा भाव नहीं देना है कि डायमंड इंडस्ट्री में डायमंड माइनिंग, और आई एम इंक्लूडिंग इवन विजनाइज टेस्ट सीरीज, मतलब आई हैव डू नॉट हैव एनी क्वाल्म देयर. सो इस टाइप के बहुत ही स्पेसिफिक फैक्चुअल क्वेश्चंस पे इतना ज़्यादा परेशान होने की ज़रूरत नहीं है. इफ़ यू गेट इट इंट्यूटिवली करेक्ट, बी हैप्पी that you got it intuitively correct. If you did not get it because of some factual information, ignore it. ठीक है?